Today we're going to do 1.1. So all of your assignments are going to have this form here. 3 regular, and then this is chapter 1, assignment number 1. We're just going to review polynomial operations. So a polynomial is a mathematical expression with variables and coefficients, numbers. And each entity inside a polynomial like this is referred to as a term. So this polynomial has 4 terms, and each term is made up of variables that have exponents and then numbers in front of the variables, and we call those numbers coefficients. So 18 is a coefficient. So is 8, what's the coefficient here? No, what's this coefficient right here? It would be -1. So coefficients come with a sign, and then this coefficient is -7. Okay? So we usually take polynomials and order them from largest exponent to smallest exponent. This one is out of order. If I did reorder it, then I would do -y to the 4th minus 7y squared plus 18y plus 8. Okay? And the first coefficient, when you put them in order, is referred to as the leading coefficient. This question asks, what is the leading coefficient? And in this case, it would be the number -1. Everybody follow that? The leading coefficient is the number in front of the largest exponent. Okay? And then the degree of the polynomial is the exponent that is the largest, so the degree is 4. Okay? Now, a polynomial can be turned into a 2-dimensional graph, and that graph has a shape depending on what is the degree. The degree kind of tells you what class the polynomial is in and what the basic shape is going to be. And then the leading coefficient tells you the direction that the polynomial goes. And then all the other numbers kind of stretch and pull and twist but the most basic structure is determined by the leading coefficient and the degree. That's why we need to know what they are. So you could have found the leading coefficient without putting them in order. You just have to identify where the highest power is, which would be right there. So if we look down at number 2, what is the leading coefficient of number 2? So the largest exponent would be this. So the leading coefficient is +9, and the degree of the polynomial is a 5. Does that make sense? Okay. All right. Let's do this. Okay. How do we add 2 polynomials together? How do we add them together? Combine like terms. And how do you know that 2 terms are like? They have the same variable and exponent. So if I gave you a handful of apples and a handful of oranges and I said, how many oranges do you have? You're going to look at me weird and say that's not a real thing. Okay? So we got to keep our apples and our oranges separately. We can count our apples, we can count our oranges, but there's no such thing as an orange. Although that might be tasty. An apple that tasted. So, looking at this, we have 2 polynomials. We have to identify which parts of the first polynomial match up with the parts in the second polynomial. We have u squareds, so -2u squared plus 3u squared would be 1u squared. And we have combined those like terms. 6u plus 7u is 13u, and negative 1 plus 4 is plus 3. What if a term over here does not have a match on the other side? Then it just stays the same when you write it down. Okay? All right? What if this was a minus? So what is negative 2u minus 3u? Negative 5u squared. What is 6u minus 7u? Negative u. And then what is negative 1 minus 4? Would be minus 5. Oh, that I really did that well, didn't I? Okay. Any questions there? All right. No, not there. Okay. What about number 12? What is that asking us to do? Right without parentheses, and what's the operation we're going to use? Add, subtract, multiply, or divide? Multiply. And we call this distributing. It's asking us to take this negative 7v squared and multiply it in to all of those. Now, when we added like terms, what effect did that have on the variable? It stayed the same. When I had some u squareds on one side and some u squareds on the other side and I added them together, I still had u squared. I just had a different number of u squareds. Multiplying is different. When I multiply negative 7v to the third and negative 5v to the third, I need to multiply the coefficients together. So negative 7 and negative 5 multiply together to be 35. And then you multiply the variables together, v to the third and v to the third ends up being v to the sixth. Why not v to the ninth? When you multiply variables together, you add the exponents together. You're here! Yay! We weren't done making fun of you yet. Not true. Thanks. Okay. So that's the first one. And then the next one, this one right here, negative 7 times negative 7 is 49. And v to the third times v squared is v to the fifth. Negative 7 times 6 is negative 42. V to the fourth. Is everybody okay with that? Yeah? All right. What if we make it a little bit more complicated? So 13, you're going to do the same basic thing, but now I have x's and y's. Oops. What happens when I multiply those? Negative 24. So I have x to the seventh and just y minus 27 x to the fifth, y to the seventh. Does everybody understand that? And the last one, so I did this one. The last one is going to be negative 7 y to the sixth. Or sorry, I just wrote down that. How about plus 21 x to the third, y to the seventh. So I recommend that you write this down in your notebook when we do the assignment. And then obviously, there's no work to show when you enter it into ALEKS, but I'm not going to collect your notes. But it's definitely a good practice to write everything down. Okay, let's shift gears a little bit. We'll go down a little more. Okay. What about this problem? Yeah. Somebody along the way has taught you the FOIL method, and it was really handy before you got here. But now we're going to be multiplying things that are larger than binomials, so the FOIL method doesn't really work. We're just going to focus on distribution. And what I mean by that is, if that 4 was not there, and it was just v times v minus 3, then I would do this. Just like we did in the previous two problems, right? And if this was not there, then I would just multiply like that. So I distribute each one of those into that second binomial. Now that we have both of them, I need to distribute the v, and I need to distribute the 4. Okay? Now you can just multiply it out like that by hand, but here's how I want you to do it, and I'm doing it specifically this way because it will help us in the future. What I want you to do is draw a 2 by 2 box. So go ahead and draw that. And then put one binomial on the top and one binomial on the left, and it doesn't matter which is which. I will put v plus 4 on top and v minus 3 on the side, and it's going to end up being the same thing even if you do it in the opposite order. Okay? So, the first square is v times v, which is v squared. Okay? The next one to the right is v times 4, which is 4v. And then down to the next row, negative 3 times v is negative 3v. And then negative 3 times 4 is negative 12. Are we all right so far? And now we look through and we find like terms. V squared does not have any like terms, so it just goes there. The v's are like terms, and they end up with plus 1v. And then the 12 just goes on its own. Okay. We can do the same thing for 17 and 18, but I want to look at 21. How do we do 21? Can I just say y squared plus 9? No, that's wrong. What I need to do is build the box, put y minus 3 on one side and y minus 3 on the other side, and then multiply normally. Y squared minus 3y plus 9. And then combine like terms. Y squared minus 6y plus 9. We good? Okay. Oh, those are the answers. Okay. Yep. That's all. Yeah, so finish your initial knowledge check, and when you're done with that, do this assignment. And when you finish this assignment, I want you to stay busy, so don't just take the rest of the day off. You need to go into your topics and work on your topics. You're not wearing your mask either. You guys don't like your grades, do you? That's okay. You don't need to apologize to me. It doesn't hurt me. All right, get to work.